Okay, so let's look at this question. So it's asked us, this is algebra. Okay, so we're going to do algebra today. Now let's look at this question 13 from the 2020 PAT paper. So consider a set of masses of different values, Ma, Mb, Mc. Each of the following three combinations have the same total mass. Two masses of Ma plus three masses of Mb. Okay, so to get that as an equation, that will be 2Ma plus 3mb. Okay. The next question, 5ma plus 1mc. That will be 5ma plus mc, one of that. Two masses of ma. So that will be 2ma plus one mass of mb plus one mass of mc. Okay. Now it says find mb and mc in terms of Ma. So because each of them have the same total mass, we can equate all of them to each other. Okay, so we label them as 1, 2, and 3. So we can equate equation 1 and 2. So that would give us 2Ma. Okay, so we'll get 2Ma plus 3mb will equal to the 5ma plus the mc. Okay, now if we rearrange this to make, because we want to find mb and mc in terms of ma, we can rearrange to make mb the subject. So we subtract 2ma from both sides. So we'll get mb equals to 3ma plus mc over 3. Okay, because we minus the 2ma and then divided by 3. Okay, good. Now we'll make some more room for ourselves there. Now, the next point is we want to get MC in terms of MA. So we can write 2 MA plus MB plus MC will equal to equation 3 will equal to equation 2. So we can have that as 5 MA plus MC. Okay, now the MCs will cancel out. So straight away we can get that MB will equal to 3MA. Okay, so that is very helpful to us because now we know that MB is equal to 3MA. Now we want MB, we have to really think about this. We want MB and MC both in terms of MA. Okay, now we have MA here, but we have MC, so that's a problem. We have, because we want it only in terms of MA. We have MB here, and that is equal to 3MA. So that's fine, MB is done. However, now we need to find MC in terms of MA. We can see that we've looked at equation 1 and 2, 3 and 2, but we haven't looked at 1 and 3. So let's look at 1 and 3. So that would give us 2MA plus 3MB will equal to 2MA plus MB plus MC. So those 2MAs will cancel out, and we will get that MC will equal, to move the MB to the other side, will equal to 2MB. Okay, so now we've got MC in terms of MB, but not in terms of MA. Okay, we've got MC, MB in terms of A. We want MC in terms of MB, but we know that MB here is 3MA, so we can substitute that in. So that will be 2 times 3MA, which will give 6MA. Okay, so I really should have labeled this. So if you are looking at this and you want to try it again yourself, you can think about this as being equation 1 and 2. Yeah, so definitely when you're following my videos, I will definitely recommend you to try the questions again and rewind and make sure that you can do all of them yourself. So that's equation 1 and 2, and we rearranged and solved, and then we got an equation for MB, 2 and 3 and 1 and 3, and we got the answer. So this was what they wanted for MB, and this is what they wanted for MC. Okay, so let's look at this question 22 from paper 22, which is also an algebra question. Okay, so we have 3 equations. However, we can treat it as simultaneous equations because we can look at 2 of them at a time. Yeah, we'll label them as 1, 2, and 3, just so you know what I'm talking about. So let's start by looking at the first one. So we want to find the possible values of x which satisfy these 3 equations. So we've got x squared equals to y. So we can substitute that straight as y as x squared into 1. So we can do 2 into 1. That will give us 2x plus x squared equals z. Okay. Now, what we want to do is we want to get something just with x and z. So conveniently, we can put 2 into 3, and that would also just be x into z, yeah? So we need to think very strategically with these type of questions because, especially with the PET, you don't have much time. So you really need to try do things quickly. So that y, we substitute it for the x squared. And then that would be 2x cubed, okay? So now we have 2 equations with z and x. So you can say this is 4 and 5, okay? And now we have 2 equations just with z and x. That should be solvable, although it doesn't seem very straightforward. It's a cubic equation that we need to solve. So the z is 2x plus x squared. We can straight away substitute 4 into 5, okay? So it's a chain. Put the z as 2x plus x squared. That will be x squared plus 2x squared will now equal to the 2x cubed, okay? Then now we can make the x cubed the subject. I realize I've run out of space here. So I'll just create a bit more space. So now we can set it equal to 0 as we know. So that will be 2x cubed. Move all that to the other side. X squared plus 2x squared is 3x squared. That will become minus 3x squared once it goes to the other side. Minus 2x equals 0. Now this is a cubic, although we can take x out because x is common. So that would be x, 2x squared minus 3x minus 2 equals 0. Now this quadratic we can solve. I'm aware that is now calculated paper, so you can just use calculator quadratic formula. 2 times minus 2 is minus 4. The 2 numbers at times to make minus 4 and add to make minus 3 is minus 4 and 1. Okay, so you can write that as 2x squared minus 4x plus x minus 2. We'll factorize the first 2, so that would be 2x x minus 2 plus x minus 2. So that will combine to 2x plus 1 because we have 2x plus 1 off these brackets, x minus 2. So that extending the x there because we just factorized that middle part will equal to 0. So we've got the solutions now. X will equal to 0 minus half or 2. Okay, that's it. Okay, so let's look at these questions. 10 students need to complete their compulsory practicals for their high school examinations as detailed in the table below. The school only has one laboratory in which several different experiments can be set up simultaneously. A maximum of 6 students are allowed in the school's laboratory for a lesson. Each practical takes 1 lesson. What is the minimum number of lessons required to complete all the practicals? Okay, so now we have 2 students, 1 practical, 4 students, 2 practicals, 4 students, 3 practicals. So how many practicals is that in total? That is going to be 2 plus 8 plus 12, okay? So that is going to be 22 practicals. However, we're only allowed 6 students in each time. So 22 divided by 6 will be 3 and 4 6, okay? So that will be 3.67. So the minimum we need is 4 lessons, okay? Okay, so the Euler number EU has no units. It is used in fluid flow calculations. It depends on pressure, density, and fluid velocity, where A, B, and C are constants. This is the formula. Find the ratio of A, B, and C in the simplest form, where A, B, and C are positive or negative integers. Okay, so first we need to define the quantities. So pressure is force over area, which is newtons over meters squared. Now, newtons can be defined as force, which is MA. So that would be kilograms meters per second squared, meters squared. So meters divided by meters squared would give us m to the -1, s minus 2. Density is mass over volume, so that would be kilograms over meters cubed. And then the velocity will be meters per second, which will be ms minus 1. Now, let's keep going with this. So we can substitute that into our equation, okay? So P is just there to the power of A. And then we have rho to the power of B. So I'll just write that as m to the -3 divided by m cubed is to the power of -3. And then meters per second to the power of C. Okay, now kilograms to the power of A and then to the power of B. Indice rules means we add that up. So A plus B, m -1 to the power of A -3 to the power of B. So that would be m minus A minus 3B plus C. Okay. And then S will be minus 2A minus C. Okay, now all of that needs to equal to 0 because we want no units. So that means the powers of all these units should be 0. So we'll get 3 equations, which is A plus B equals to 0, minus A minus 3B plus C equals to 0, and minus 2A minus C equals to 0. Now, as before, this is something they wanted to be able to do in PAT, which is to solve 3 simultaneous equations together. Equation 3, this can simply become C equals to minus 2A. So from here, we can just let A equal to 1. So if A equals to 1, then B will equal to -1. And we just need the ratio. We don't need to have all the solutions. And B would equal to -1 because A is minus B. So that means B is minus A. And C equals to minus 2A. So C would equal to -2. So then the ratio will be of A to B to C will be 1 to -1 to -2. Great.